So let's start with the seminar, with the new seminar in the ICCG series. Today we have with us the Professor Stefan Uhlenbrook. He's the coordinator of the United Nations World Water Assessment Program, which is a UNESCO program, and the director of the Program Office on Global Water Assessment in Perugia. Before, he also worked in the UNESCO International Water Education Institute as a professor of hydrology, as well in the Technical University of Delft. Well, his background is mostly on hydrology. Today he's going to make a presentation on the well, mostly based on the last World Water Development Report, in which he will focus on wastewater. So, Stefan, the floor is yours. You can start with your presentation. We have half an hour for the presentation. Then we'll have more or less 15-20 minutes for the questions that the audience will pose along your presentation. So thank you very much for being here, and you can start when you're ready.
Good. Hey, thank you so much for the nice introduction, and it's my pleasure to give this presentation today, and I'm looking forward to the discussion. I've been instructed that I first should present the topic for half an hour, not longer, and then we enter a discussion. Well, in general, if the audience has some urgent burning questions on a specific topic or a slide, I wouldn't have a problem, but I think technically it is easier if we do it one after the other. Good. So the topic of my title of my presentation today is water and wastewater, and I would like to explain to you why I think these are centerpieces for the so-called circular economy. And I'm with UNESCO, and I'm leading the World Water Assessment Program. It's based in Perugia in Italy. Most of the results that I'm going to present today will be based on the 2017 report of WWAP. WWAP is the World Water Assessment Program. And the report is the United Nations World Water Development Report. And in a nutshell, what this report shows is that wastewater is really an untapped resource. And it's not waste at all. I think we should get rid of that terminology that wastewater is wastewater. But maybe in many other languages, it's not called wastewater. For instance, in French or Spanish, or so, it's rather called water that has been used before. And maybe that's a better title. But I hope in the next 28 minutes you will agree with me that wastewater is not a waste. It's rather a resource. And what I would like to demonstrate is that improved wastewater management generates not only environmental benefits, but also social, environmental, and economic benefits. And they're absolutely critical to achieve the Sustainable Development Goals. But before I go into the report, I would like to set the scene. This presentation is put into the context of the circular economy. Circular economy, we too much think along linear lines. You know, we take our natural resources, we manufacture something out of that, we transport that to the user. The user is consuming or using the good and throws it away. That's a very linear way. In the circular economy, we try to change. We would like to use natural resources, manufacture something, but before we, after consumption and use, just throw it away, we try to recycle and reuse it again and again. And aspects of that circular economy are that we try to preserve the natural capital and enhance it even, that we try to maintain the value of products as long as we can. So we try to use a plastic cup of water, or using drinking water as long as we can, and really minimize the resources loss. And minimize the waste, try to be a part of the low carbon economy. That means that minimizing the carbon emissions, and that has also many feedbacks in different loops. I come to that later. Benefits of such a circular economy are that it contributes to sustainable economic growth, because of this circular thinking, this circular loops. There's many feedback mechanisms into the economy that can also help saving costs, but also generate employment and generate jobs and new opportunities. And with being more careful with using natural resources, we also save on energy wastage or energy use in general, reduce on carbon emissions and pollution, etc. So there are quite a number of different advantages in that circular economy. Why do I think that circular economy is so important? And like only one slide is since the Club of Rome discussion in the 70s that is accompanying us. So so the years changed a bit, but this is one of the later predictions just for energy, different metals and other materials that are very critical for our economy. You can see that, I hope you see my mouse, say in the energy part, in 2010 we have oil, coal, gas, uranium, some metals, antimony, lead, indium, rare earth elements, etc., zinc, silver. And if you look at this, is a picture of my son, you know, a recent picture from 2016-17. In this age, you know, he enjoys the benefits from all these different materials. But if he will reach my age, and that's in some 40 years or so, he will have my age, and then he will probably live in a world without any oil, without coal, or just a little bit of coal, but reduced already consumption, gas reduced, uranium reduced, no antimony, no lead, no indium, etc., etc. So he will live in a world that will have to look very different of what we have nowadays. Yeah, and then he will only reach my age, you know, and that's almost 50, so that's not really old. And if you look at other, and I come to wastewater now, wastewater has a lot of phosphorus. For instance, in the urine, we have a high percentage of phosphorus. Globally, it's expected that this will be exhausted in some 50 to 100 years. And another message is that more than 80% of this phosphorus comes from these countries that I mentioned there, and actually the vast majority comes from Morocco and Western Sahara. So these are countries where we are highly dependent on, and politically they are not maybe always most stable, or might develop differently in the future. So you see our strong dependence on phosphorus, which is critical for food security on very few countries, and actually it's largely on Morocco and Western Sahara. And if we don't find ways to recycle, reuse phosphorus, we will run out of mineral phosphorus very soon. In the next 20 minutes, I would like to show that water and wastewater is really a very central part of that circular economy, and we will have to manage wastewater rightly by reducing pollution at the source, removing the contaminants out of the wastewater flows, and reusing the reclaimed water as much as we can, but also not only the reclaimed water, but also we should recover the interesting byproducts. Byproducts of wastewater include, for me, beside phosphorus as a fertilizer, but also energy content and other metals. We come to that. Good. I skipped this, maybe a bit too much details, but now I want to move to the wastewater report, and that's our 2017 report. Has been launched some 3 weeks ago in South Africa. Here you see a picture also just after the launch. President Zuma sitting in the middle holding up our report, and there we had senior representatives from the African Council for Ministers for Water. Different water ministers are in this picture. I'm smiling as well, and my boss from UNESCO is also there, and that was the launch event. But since then we have been presenting it at quite a number of locations worldwide. Last week, for instance, in New York at the UN headquarters to the member states of the UN. Let me start with the first chapter where I would like to review quickly the state of the water resources globally. And obviously I could speak about that for quite some time, but I would like to give particular emphasis on water scarcity aspects as well as wastewater aspects. Globally, the demand to water has been increasing. Water has been consistently taken out of the systems, or withdrawal has been increasing for 1% every year. If you always take 1% more out of something and the resource is finite, then at one stage it's nothing left anymore. So it's an unsustainable behavior. Some 70% go to agriculture, some 20% to industry and energy production, but only 10% here in the top right, excuse me, bottom right picture is actually the domestic water use. And from this, we drink less than 1%. The overall, our consumption of water for drinking water is far less than 1% if you look at our global demand. Future predictions, I skipped a couple of detailed slides on how different scenarios will look like, but overall, the agreement is that because of the increased food production that is necessary, because of the increased industrial production and energy consumption in particular, we will have a continuous increase in the water demand, and that cannot be satisfied anymore everywhere. Another thing that is impacting future water resources is the accelerating urbanization. By 2050, we will have some 2.3 billion people living in cities. You see on these figures where the growth in the population is happening, and particularly in the developing countries in Sub-Saharan Africa, Southern Asia, Northern Africa, Middle East. There you see quite significant increase, and it's particularly the urban population that is increasing quite significantly. Where do these people live? This is a proportion of people living in slums from the past years. And from the past years, sorry, there's my cell phone in the background, that particularly in Sub-Saharan Africa and Southern Asia, where already almost 50% or almost 2/3 of the population living in urban slums, peri-urban, highly densely populated areas, that is continued to increase, and that's where the majority of the people are going to live. I hope the call was not for me, and I hope my voice is good and understandable. I said before that the water resources likely will not be able, we will not be able to satisfy these, and you see here increasing water demand in different areas, and the water scarcity, particularly here in the parts of Northern Africa, Southern Africa, Middle East, Central Asia, Southern Asia, this area, and already now 2/3 of the global population live in areas that experience water scarcity. 500 million people live in areas where the demand locally is already twice as high as the water that can be produced in locally produced in a sustainable way. So this is unsustainable for already 500 million people worldwide. Climate change adds another dimension to this, and it will exacerbate the frequency and the intensity of floods and droughts. Not everywhere to the same extent, but what we observe in many places is that places that are already dry likely will become even drier. Other areas that are wet and are experiencing flooding, they likely become even exposed to more intense, more severe and longer flooding in the future. So together with these urbanization aspects and all the other global changes, climate change will add to that and will rather intensify the water scarcity problem. Then we move to wastewater, because we see globally a degradation of water quality. I hope you can see the reddish and orange colors on this map, and you can see that about large parts of the river stretches are exposed already to severe pollution of pathogens. And also in the next slide you see a lot of orange and red, and that means there's an increasing trend of biological oxygen demand. That's an indicator for the lack of wastewater treatment, and you see the vast majority of the river stretches mapped here in these parts of the world are exposed to increasing concentration in the rivers. I hope everything is okay with the sound. I don't hear anything else, and I will just continue. Sanitation systems, I said that this is one of the problems is the lack of sanitation. So wastewater is not only domestic wastewater, but only 26% of the urban or 34% of the rural population actually lives in a system where the wastewater services are so effective that humans are prevented from contact with any excreta. And you see here the different types of sanitation, different parts of the world. While in Europe and in Europe mainly we have 72% connected to a sewer system. You see that in Sub-Saharan Africa, for instance, is only 7%, and the vast majority of people still depend on septic tanks or pit latrines and other things which are not absolutely safe when it comes to the exposure to human excreta. Globally, we have more wastewater than ever. Every human use of water creates wastewater. So it's not only the wastewater that we generate in our toilets. I was speaking about sanitation in the previous slide. Now every use is producing wastewater. Also industrial processes or agricultural processes produce wastewater. I said before that some 70% of the withdrawal, the water that we take out of the system, is used for agriculture. That's what you see here. And 38% is used for agricultural consumption, so that's water that is used in the agriculture system. But actually 32, almost half of this water actually goes back to the environment with agricultural drainage. Yeah, the same you observe, a similar pattern you observe for municipal water. Of the 11% that is taken for municipal water use, 8% go back as municipal wastewater, and industrial wastewater is also 16% compared to only a small percentage actually used, actually really consumptively used in industrial processes. From all this wastewater, either from agriculture, from domestic uses, or from energy and municipal uses, we observe that more than 80% of the global wastewater is actually released to the environment without being properly collected and treated. Over 80%, and that is the reason why we have this degradation in the water quality globally. Let me move on to my second point here. What does that mean if more than 80% of the wastewater is not treated? And I hope you can see in the background this little movie we have here, and that's from a slum in Africa in this case. And what my point is here, that this has very severe implications for the health of the people and in the environment. If you see here, these numbers here is a world map of access to improved sanitation, and while in the north, the so-called global north, more than 90% have access to some improved sanitation, it's in many southern or low-income countries that less than 50% of the people actually have access to improved sanitation. 2.4 billion people, so a third of the, almost a third of the global population doesn't have access to it globally still, and almost 1 billion people still practice open defecation. That means they don't have any access at all to a toilet, and they just do the necessary where they can out in the environment somewhere. This is not only a question of hygiene, and it's also a question of dignity in particular. In the Sustainable Development Agenda, which I consider a very exciting agenda, the target is to halve the proportion of untreated wastewater. You see here the SDG target 6.3, which actually states that halving the proportion of untreated wastewater and substantially increase recycling and safe reuse is envisaged, and is that what we want to see happening, and that's what we want to commit. What needs to happen if we want to do that? That would mean that in low-income countries we need to reduce untreated wastewater from 92 to 46%. This is very significant. In the high-income countries, from some 30% to 15%. So we can see that halving that proportion really requires significant change in the way we manage wastewater, in particular in low-income countries. And how could that happen? Well, it likely will not happen in the next 13 years, which is the time left for this achieving the SDG 6 and the whole 2030 agenda. That will not happen if we only go for high-tech and very expensive solutions. We have to consider also robust, effective and functioning low-cost technology that can also work well in a low-income country context. Let me come now to the how, and that's maybe you might consider as the most exciting part of my lecture, I hope so, that because we want to meet the challenge for improving wastewater management, what needs to happen? And the following 4 things need to happen. We need to reduce the wastewater that we produce. We need to remove the bad things out of the wastewater. Then we need to reuse the wastewater again and again and as much as we can. But finally, a reuse might be not possible anymore. And then before deposing it to the environment, we need to recover the good things that are still in the wastewater. So we really have to see wastewater not as a burden, as a nuisance. No, we should, as something we want to just get rid of and discharge to the environment. No, we really have to see wastewater as a resource. Yeah, and I would like now to discuss a little bit these 4 R's. The first is reducing. Reducing wastewater generation means just using less wastewater, because all the water we use will become wastewater later. So therefore, reducing is the first, and avoiding a problem is always less expensive than trying to repair the problem later. So reducing or preventing wastewater generation is the most important and has to happen at the source. That means not only the total amount of water, but also means different ingredients that we put into the wastewater, chemicals, organic materials, heavy metals, etc. We should really try to reduce the use of it and the discharge into the wastewater streams. After reducing, we should, if reducing is not possible anymore, we should collect the water in some pipe systems and treat it. Treatment can be a natural system as well as a physical, biological, or chemical treatment water system. These are engineering systems. Natural systems should not be underestimated in their potential. Often they're also simpler and need less investments. For instance, in this example for Brazil here, in a simplified sewage system, it was estimated that it's roughly half the cost compared to conventional sewage treatment, because a large percentage of the treatment is also going into the piping to the collection network, and if we do that in a centralized big way, it can be more costly. Not necessarily it's always that the decentralized systems are financially better. Bigger systems in certain contexts can also be more effective, and certainly with recapturing the interesting byproducts out of the wastewater. But overall, decentralized systems can be financially interesting, effective, and lower in costs for setting up the wastewater treatment system or for operation and maintenance. For operational maintenance, I also would like to stress again that ecosystems can be very important. Ecosystems can take over part of the engineering solutions that we do in plants. This is a picture from a constructed wetland in North America, and what you see there is different ponds, and here the ecosystem is managed in such a way that it performs wastewater treatment processes, and these systems again are much lower in terms of upfront capital investment as well as in operational and maintenance cost. Good, let me come to number 4. After we did some treatment to the water, we can reuse it. We can sometimes also just reuse wastewater without treatment, but that's hardly the case. Often we have to treat it. And treatment is not necessarily that all the water needs to be treated to drinking water standard, so crystal clear drinking water. No, sometimes it's enough to treat it for purpose. We call that treatment for purpose, and it then can be reused, for instance, for irrigation, so in agriculture, for aquifer recharge, or for industrial processes, or for drinking water. I come to drinking water at the end. But again, not necessarily we have to do the full expensive high-end treatment up to drinking water standards. It can also be treated for purposes and whatever we want to do with the wastewater, how we use it or reuse it. Use of wastewater can really offset the water scarcity problems we have in many parts of the world. I showed some pictures earlier in this presentation. An example from Accra for reuse in urban agriculture. This is a good example where the average income of the local farmers, again, farmers in an urban context, they were reusing wastewater and were generating per farmer some $400 to $800 per year, and quite a significant market value, and that helped 200,000 urban dwellers to benefit from that production. So it helped their economically for their livelihoods, but it also helped for food security in that urban context. Finally, after we treated it, we should recover also all interesting byproducts. Wastewater has a fertilizer. I mentioned phosphorus before. There can also be there's also a lot of nitrogen in the wastewater. Potassium is another important nutrient for plant growth. Furthermore, there's organic material, and this organic material can be used as bioenergy productions, and so it's an important source of energy. Wastewater treatment plants can be designed nowadays that they are energy positive, meaning that they're not only producing enough energy for the treatment plant itself, but also for producing enough energy to export energy out of the plant. Considering these byproducts adds additional revenue streams because we can earn money with it, and some people call it a bit informally like making profit out of shit. But that might concern you a bit, the word of language. But that's what it is. You reuse the wastewater and you market that properly, and that can help to also finance the necessary capital investments that are there. So we really have to see wastewater as a resource. Here in this picture, what you see there is fertilizer, phosphorus-rich fertilizer that is completely recaptured out of wastewater and can be used for fertilizer in agriculture. Let me come to the last part of my presentation, and well, I outlined what should be done, and now the question is, how do we get there? What needs to happen? What is the enabling environment that we need to generate? And that's what we call the enabling environment for change. First, well, as a scientist, you always expect for me to say, well, we need more research. Well, and research and technology, and I agree we need research and technology, but it's often not technology and research. It's often the legal framework, the soft parts of the enabling environment that enables us to use the technology that we have already developed. So it has to do with legislation and regulatory frameworks. Second, we have to get into new finance models for wastewater management, and also in the circular economy we have to rethink of what kind of costs and benefits and revenue streams we want to attribute to different material fluxes, and wastewater is part of that. And we should also capitalize on the revenues that can be generated out of wastewater. Furthermore, investments in wastewater management can be really beneficial for society. UNICEF has estimated that better sanitation pays off with the factor 5. So every dollar you put in better sanitation systems pays back to society with the factor 5 for the society, because of people getting less sick, less health costs, people are productive, can work, etc., etc. So investments in this wastewater is really a good investment for society. Number 3, we have to minimize the risk for wastewater. I mentioned repeatedly that we should reuse it also in agriculture. Reusing wastewater without proper treatment can expose people to the pathogens, to the unhealthy part of it or perspective of it. Therefore, and we also saw by putting this report together that particularly vulnerable groups, especially women and children, are the ones who are exposed the most to wastewater, to the potential risk of wastewater. Therefore, a so-called multi-barrier approach is important to secure wastewater reuse from the wastewater generation to the irrigation, to the harvesting of the products, to the use of the agricultural goods in the market. That there's really along the whole chain an approach to ensure a safe reuse. Number 4, we need more research and capacity development. Certainly more research in trying to optimize further the energy, the bioenergy generation out of wastewater. Also, the capacity building is very important, that people actually know what possibilities we have and can really capitalize on that. And that is certainly true in the developing world, but not only in the developing world. Capacity building is necessary throughout. Finally, this is my last point. You can design any beautiful scheme without support from the public, without the necessary awareness and social acceptance. Every scheme is useless and will not be taken up. There's many examples in the literature where reuse schemes of wastewater were not taken up, were not successful because the public was not properly informed. And that brings me to this little movie here at the end, and I really hope you can see that. What you see is an astronaut at the ISS, the International Space Station, and he has a drop of water in space. As you know, in a space station you don't have any rainfall or any groundwater body or any spring or whatever. All the water that is on the spaceship has been there from the beginning, and the ISS is up in space since 2017. And as it's since 2000, so since 17 years. So since 17 years, people living in that spaceship are using and reusing the water all the time. So maybe the water in the morning it was T, in the afternoon it becomes P, and in the evening you use it to brush your teeth. So you can see it's really a closed system of recycling again and again. And none of these astronauts ever became sick. So you see, technology makes it possible. It is possible to have closed systems and really thinking in a circular economy. But we have to overcome the so-called Yuck Factor. That's the factors that say, I don't want to use wastewater. And that has a lot to do with awareness raising and public acceptance. Singapore, for instance, they use a lot of wastewater also for drinking water, but they don't call it reclaimed wastewater. They call it new water. And new water sounds much better and can be creates much more social public acceptance than calling it reclaimed wastewater. So these are my take-home messages from the report. Wastewater is increasing worldwide. The vast majority is related to the environment without any treatment, more than 80%. Affordable, low-cost treatment options are available. It's not necessary that we only invest in high-end, high-technology treatment. I'm not saying that high technology is not necessary. We should stop that. No. But if we want to achieve the Sustainable Development Goals, we really have to think about low-cost technology as well. Then it can be a reliable source of water, but also a reliable source of energy or nutrients or other recoverable byproducts out of the wastewater. I think it's in the circular economy a key component, because it really demonstrates this thinking in cycles instead of a linear thinking. And that also creates new business opportunities, because recycling and reusing also creates new jobs and business opportunities that are helpful. There are many benefits of wastewater management, and these benefits usually outweigh the necessary costs that are there. Upfront capital investment needed for better wastewater management, but there are many benefits in terms of human health and development and environmental sustainability that really outweighs the costs. Finally, I hope I was able to explain that wastewater is absolutely critical for achieving the SDG. So I started with the circular economy and would like to close with this picture. You see, a circular economy goes from the resources through the manufacturing, consumption, use, and to recycling. I think water and wastewater is absolutely central in that perspective, and I'm looking forward to the discussion now. Thank you very much.